Hello everyone and welcome to another exciting video. In today's tutorial, we'll be creating a self-supporting trapezoidal profile family, or TRP for short. On the screen, I have a cross-section example with dimensions that I will be using in this example. We'll start by building a parametric 2D profile in the generic family of a single trapezoidal shape, then nest it into a generic family. After that, we'll create an array and finally nest this into a new family using the framing template. Let's get started. Open up a new generic model, family template, and go to the front view. Here, I'll begin by constructing the parametric trapezoidal profile. First step, place the reference planes. These planes serve as the framework, constraining and supporting our geometry. Throughout the tutorial, I'll be using plenty of hotkeys to save time, a handy trick when working in Revit, so I highly suggest you learn to use hotkeys on a regular basis. Reference planes are all set up. The next step involves adding dimension line to the reference planes. The dimension values are a bit large and take up quite the space on screen. To scale it down, I adjust the scale in this view. So the dimension lines play a crucial role in defining, controlling, and displaying the size and positioning of elements. They are essential for creating parametric relationships within a family by connecting them to the reference planes. When the value in the dimension line changes, the reference planes adjust accordingly. Alright, moving on to our parameters. I will say that parameters are essential since they bring flexibility, control, and adaptability to the components you create. I place the height, length, and thickness parameters within the dimensions category. It's crucial to maintain a well-organized parameter system. For example, parameters in this category are intended for end-user modification, while parameters that will function in the background of the family are not intended for the end user to change are placed in the other category. Next step, link the parameters to our dimensions by selecting the dimension line, navigating to the top menu and choosing the relevant parameter from the label options. Repeat this process for all dimensions so we now control the reference plane with our parameters. Once again, I will change the scale to better see text and values above the dimension line, and doing a little bit of cleanup, moving the dimension lines and making this family a bit more presentable for anyone who will open it up. The last step in the process of creating this nested family component is the visible part, the actual geometry. Here I will be using the extrusion geometry tool. The extrusion tool is used to create 3D solid geometry by extending a 2D sketch along a specified depth. Extrusions are versatile and commonly used for making objects like walls, countertops, beams, or any element with a consistent cross-section. Personally, when drawing up the 2D geometry, I prefer to position the lines adjacent to the reference planes rather than directly on top of them. This approach offers, I think, better control when aligning the geometry to the reference planes later on. You see the geometry being locked to a reference plane. Make sure when aligning to press the little lock, making sure the reference plane and geometry are connected. And it is important to mention that we always constrain our geometry to the reference plane and not geometry to geometry. It will help maintain stability and the integrity of the family with no errors. Okay, so here I am dimensioning inside geometry sketch mode and I am connecting it to the thickness parameter. I usually try to avoid doing this because it will create a more unorganized and, in general, messy family, but sometimes you have to break the rules. Finish up the geometry by connecting all the lines together and hitting the green check mark. The geometry for one single trapezoidal is done. We go ahead and change the parameter values to check if everything works as intended. This operation is called flexing, and I would recommend doing it regularly when developing a complex family, so you don't end up at the end with a highly advanced family that doesn't work. Gonna be a nightmare to find the errors. I forgot one thing, adding reference planes and connecting the geometry to a length dimension line. Just quickly set it up and connect the dimension line to a parameter. Then do a quick purge to delete any unused elements in the family. This will help it run more smoothly and reduce the file size. So all done with this nested component, which will be part of an array. Save it with a logical name on the desktop for easy access. Start a new family. This will be our host family for this nested component. Return to the family with a single trapezoidal element and load it into the new family, making it a nested component within the new host family. So a nested component is a family inside another family, instead of creating complex geometry and parameters from scratch in a single family. Nested components allow you to build individual elements separately and then bring them together into a host family as a single unit, making it easier to control. As you will see here in this video, the nested component here provides access to the center line of our object, so we can align the center of our family with the reference planes, which is key to working with arrays. As of now, the parameters created in the nested family are not accessible to the end user if we load it into the main Revit project. So we need to create the same parameters inside the host family that we want the end user to access from the nested family. In addition, we add parameters that will control the array. The array parameter needs to have the data type set to integer. It is useful because it ensures that only whole numbers are used. Continue to add the parameters L1, L2, and L3. The next parameter, total width, will be a support parameter based on the total width of the trapezoidal element and help us place the element and get a better control of it in the array. That applies to the next parameter as well. Control our array. Add some numeric values to the parameters. Without a valid value, we would not be able to connect the parameters from the host family to the nested family. To get the total width, I will use the formula tool and summarize the L parameters, so the total width of the element will always be correct based on the input L values and the actual width of our element. Setting up our reference planes. Preparing for the array. With these planes, I control the position of the element and the distance between each array, since the reference plane will be connected to the total width formula, which again is based on the L parameters that decide the width of each element, making the distance between each element 0 with no spacing. To make the nested parameters available to the end user, I connect them to the newly created parameters, meaning that when changing the parameters in the host family, the parameters in the nested family will be updated. Let's move on to the array. So, an array, it's a versatile tool for creating multiple instances or copies of an element along a line with a fixed or user-defined spacing. Arrays allow for simultaneous manipulation of these elements inside the group, meaning changes made to one element in the group apply to all. I will be using move to second option in the array bar. This setting specifies the spacing between each member of the array. Additional array members appear after the second member. Remember, it is the second member of the array in relation to the first member that determines how the array will be. So I will focus on aligning and constraining members 1 and 2 of our array in relation to one another. Connect the array number to the array parameter. Mark our array and find the parameter in our top bar. In this example, I will do a double nest. I will load this family, which contains a nested component of a single trapezoidal profile, and the full TRP element contains the array of the nested component into a new family with the template structural framing. Since this template contains some features I would like to use, I will constrain the array element to the predefined reference planes that this template comes with. Since the length parameter is an instance parameter in the host family, I can drag the array using the handles. And since this is a new host family, I will once again set up the parameters and connect them to the nested family. I would like the end user to change to make this family fully parametric. The parametric part refers to creating objects or models that are defined and influenced by a set of parameters. These parameters can take various forms, such as numerical values, rules, formulas, or relationships between different parameters. These factors collectively control the design of the object, allowing for flexibility and adaptability. When a Revit family is described as parametric, it means that it has built-in parameters, properties that control its geometry, appearance, and behavior. These parameters allow the family to be flexible and adjustable, enabling users to modify the family's properties to fit specific needs in a project without creating a separate family file for each variation. Associate the last parameters for the nested components, and change the material for model behavior to steel. This helps define specific behaviors of elements based on their material. For steel, enables both cutback and shape handles for the element, and especially the shape handles are crucial in our case, making it easier to model the element when in the main project. Great, the family is now loaded into the main project. Let's do some testing by adjusting the values to make sure the family behaves as expected. Everything looks fantastic. The family responds perfectly to the changes. The final step is to create specific family types with fixed values based on the TRP product specifications, so the Revit family matches the actual real-world TRP dimensions and shape. To do this, open the family again and go to the Family Types menu. At the top, select New Type, then enter the real-world product name and set the exact dimensions. I'll create a TRP45 and a TRP70. After saving, load the family back into the main project, then open the Properties risk menu and select the desired type from the drop-down menu. As you can see, the family changes shape based on which of the types I select. And that wraps up this tutorial. Don't forget to like and subscribe for more helpful videos.